So today we're going to be talking about scientific notation. So if you have your notes with you, I want you to go ahead and turn this page towards you. And you're going to grab the bottom, and you're going to fold the bottom to the line slightly above standard to scientific. Then you'll grab the top and fold it downwards. So now in front of you, you should see scientific notation. So what is scientific notation? So the people that mainly use scientific notation are going to be scientists and mathematicians. And they invented this because it was a way for them to reduce the amount of error they were having in calculations. Now, how easy do you think it would be to leave out a zero in a number? For instance, between 90 billion and 9 billion. That's a lot of zeros to keep track of. So they came up with scientific notation to kind of help eliminate some of that error. Now, scientific notation can be a short way of writing a very big or very small number. So here, this is scientific notation form. So here we have our decimal. Now, there can only be one number in front of your decimal when it is written in scientific notation form. And that number has to be a number that is 1 through 9. Notice how 0 is not a number 1 through 9. So here the number in front of your decimal can't be 0. And again, notice how the number 1 through 9 is a single digit. So here, this is single digits only. So that means that you can't have the number 10, the number 11, 23, 745. It has to be one number that is 1 through 9. And then we have times 10. It'll always be times 10 to an exponent of 5, 6, whatever. It can either be positive or negative. So if you have a positive exponent or a negative exponent, that doesn't matter. And I'll tell you what that exponent's going to mean in a second. So if you go ahead and, if you have all this written down, you can go ahead and open that up. And you will see this is an example of scientific notation. Notice there is one number in front of the decimal. That is a number that is 1 through 9. It's a single digit. And then we have 0.42 times 10. Remember, this is always going to be here. And then our exponent here is a positive 5. So going up top, first we're going to talk about going from scientific to standard form. So I have 9.77 times 10 to the 8th. So notice how our 8 is a positive exponent. So since this is a positive exponent, this means we will move our decimal right. So I'm going to start off by rewriting my numbers. So 9.77. So I'm going to take a different color to kind of emphasize. So since my exponent is 8, I'm going to put my pencil or my pen at the decimal point, and I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8 times. So I move my decimal point here. Whenever you rewrite your number, you're not going to include that decimal point. So here, this gets zeros. So when we rewrite this, I have 977, and then I have 1, 2, 3, 4, 5, 6 zeros after. So starting from the very right, you need to place your commas. So every 3 numbers gets a comma from the right. So 1, 2, 3, comma. 1, 2, 3, comma. So here you have 977 million. Now, I would like to emphasize something. I saw a handful of students in years prior look at the exponent. They would see 8. So whenever they were given their answer choices, they would go look for the answer choice that had 8 zeros. That is not what scientific notation to standard form is. Again, it's how many times you're moving your decimal. So again, here you can see this is 6 zeros. This is and my exponent is 8. So that exponent does not tell you how many zeros there are. So then we have example 2, 4.1 times 10 to the negative 5th power. So here I have a negative exponent. So since I have a negative exponent, that means that I am moving my decimal left. So I'm going to start off by rewriting my number. I have 4.1. my exponent is a -5. So this means I'm moving my decimal left 5 times. So I'm going to put my pen at my decimal point, and I'm going to move it 1, 2, 3, 4, 5 times. Here's my new decimal point. This decimal point can get crossed out, and now here gets zeros. So this equals 0. So I have placed my zeros, so now this equals 0.000041. So again, that's going from scientific to standard. So now we're going to go ahead and open this next flap up, and we're going to look at standard to scientific. So standard to scientific. So example 3, I have a number that is very small. So small numbers are numbers that are numbers less than 1. So if you have a small number, this means you have a negative exponent. So here I have the number 0.000056. Now, whenever we're trying to take it into scientific form, I want you to start off at the very left, and I want you to identify where your first number, that is 1 through 9. So here I have a 0. I can't place my decimal there. 0, can't have a 0 in front of the decimal. No, 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 no. Oh, here I have a 5. 5 is a number that is 1 through 9. So once you identify your first number that is 1 through 9, you can go ahead and place a decimal point there. If I had placed my decimal point after the 6, I would have had 2 digits in front of my decimal, and remember, you can only have 1. So now we're going to count the number of times, or the number of spaces between my 2 decimal points. So here this is 1, 2, 3, 4, 5, 6, 7 times. We moved our decimal 7 times. So when we rewrite this, this is all we include, 5.6. You don't need to include all of the extra zeros. So this is 5.6 times 10. Since my number was very small, again, I have a negative exponent of 7. Okay, then we have example 4. So here I have a big number, and big numbers are numbers greater than 1. So even 8 can be considered a big number. So big numbers, that means we get a positive exponent. So on my number, on 2 trillion here, notice how it is, we do not have a decimal point there. So whenever your number does not have a decimal point given to you, remember, your decimal is at the very end of the number. So now since I'm going to scientific, I have to place my new decimal point after the first number, that is 1 through 9. So starting off from the very left, I have the number 2. 2 is a number 1 through 9. So here I can go ahead and place my decimal. Now I need to see the amount of spaces I moved from my original decimal to my new decimal. So starting here, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we move this 12 times. So whenever we rewrite this, you can either just write 2 or you can put 2.0. So 2.0 times 10 to the 12th power is my answer. Since it was a big number, again, it gets a positive exponent. So now let's move on to some multiple choice examples. So here it says write 251 in scientific notation. So here I have a big number. That tells you should have a positive exponent. So you can go ahead and eliminate A and E. Now remember, the number in front of your decimal can only be a number 1 through 9. It can't be a 0, and it can't have double digits. So I can eliminate B because it has double digits, and I can eliminate D because it has a 0 in front of the decimal. So based off of process of elimination, you have solved example 5. But it's not always going to be that easy. So So here we have written 251. So remember, your decimal gets placed at the very end of your number. Now you're starting off from the very left, trying to determine where your first number that is 1 through 9. So starting off at the left, I have the number 2. Now, number 2 is a number that is 1 through 9, and it's a single digit, so I can go ahead and place my new decimal point here. So now all that's left to do is determine the amount of spaces I move from my original to my new, which was 1 2 times. So here, whenever I rewrite this, this is 2.51 times 10. Since my number was big, this is a positive exponent of 2. So again, this matches C. Okay, example 6, it says which shows 3.002 times 10 to the 12th in standard form. So I'm going to start off by rewriting my number, 3.002. My exponent is a positive 12. So if I have a positive exponent, we move our decimal right. So from my decimal point, put your pen or pencil there and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the right. This decimal gets crossed out, and then here, remember, we put zeros. Now, it's very important that you rewrite your numbers. So here, this is 3002, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros after the 2. And then starting from the very right, we need to count every three numbers and put a comma. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So we have 3 trillion, 2 billion. Right away, we could have eliminated D and E because this positive exponent of 12 tells us that we will have a big number. Now, there should only be a 3 in front of this comma, so we can eliminate A. And now it's just left to B and C. So we said there had to be 9 zeros after the 2. So here I have 9 zeros, so B is good. And C, I have 12, so that's not my answer. So here, B is your answer. Okay, so that was scientific notation.